then, as I mentioned a while ago, there's another way that we can define the cross product of two vectors using determinant. That's 3 by 3 determinant. And we're going to employ the basket method. So copy the matrix, 3 by 3 matrix. Then what you will do is to add down the first two columns in your given 3 by 3 matrix. Okay, then let's now do the basket method here. So start with the upper left part. So multiply now. I times -1 times 1, that's negative I. 3. Then you have j times 3 times -2, that's negative 6j. Then k times 1 times 3, we have it as 3k. So if you want, you can also do this manner, and that is, you can cross. So I times -1 times 3, that's, you have it as, sorry, that should be 1, no? I times -1 times -1, that's negative I. Then you have negative 6j, then you have it as positive 3k. Then the other part now will be, so you have here minus, so multiply this part here. So that's positive 2k. Then this positive 9i. Then this is positive j. So simplifying now, we have it as negative I minus 9i. That's negative 10i. Negative j minus positive j, that's negative 7j. Then positive 3k minus 2k is positive k. Or we can also write this as in bracket or component form, that's negative 10. Then this is negative 7. Then this is positive 1. So we have the same answer obtained using the cofactor expansion. Let us solve problem number 2. So we have here, let vector u equals 2, -1, 3 as its component, vector v equals 0, 1, 7 as its component, then vector w equals 1, 4, 5 as its component. Then we're going to find quantity u cross v cross w. So we have here problem number 2. So let's find first u cross v. So forming now the determinant, or rather matrix, which is 3 by 3, we start with the first row having I, j, k. Then the second row, we have the components of your vector u, 2, -1, 3. Then vector v, 0, 1, 7. So let's just employ the basket method because it is easier to apply. So we have here now I, 2, 0, then j, -1, 1. So just copy the first two columns. So obtaining now the cross product, so starting from the upper left corner again, so multiply I times -1 times 7, that's negative 7i. Then you have j times 3 times 0, that is 0. Then k times 2 times 1, that is 2k. We can check again by having mark on those numbers diagonally. So starting here, so we have multiply, that's negative 7i, then this is 0, then this will be 2k. So that's correct. Then we now have minus, here we have 0k, then we have here 3i, then 14j. So we have here u cross b equals, let's combine similar terms, negative 7i minus 3i is negative 10i. Then this is 14j, negative 14j, ij, right? So that's negative 14j, then positive 2k. Then the result here, we can write it in bracket form, negative 10, negative 14, then positive 2. Then we now have the cross product result u cross b cross w. So let's have that. U quantity u cross b cross w now equals, forming now again the matrix ijk. So we have now u cross b is negative 10, negative 14, 2. Then lastly, we have w vector 1, 4, 5. Then copy the first two columns, I, negative 10, 1. Then you have j, negative 14, 4. So with that, u cross b cross w now will have the resulting expression such we have here, I times negative 14 times 5, that's, we have it as negative 70i. Then that's positive 2j, then negative 40k. Then you have this minus negative 14k plus 8i minus 50j. So combining now similar terms, u plus b plus w will now have negative 70i minus 8i, that's negative 78i, 2j minus 50j, that's positive 52j, then minus 40k minus 14k, that's 26k, because this becomes positive. So this is the answer we obtained, or we can write this as negative 78, 52, and then negative 26 in bracket form or in component form.